And now it's time to go over the Unit 5 practice test in preparation for the test tomorrow. Hopefully you all learn from all your mistakes and you'll be ready to go tomorrow and do a great job. Yay! All right. Number 1, some of you thought the answer was B, and those I corrected, but there's only one answer, and that's A, because when I plug in 2, I get 8 is less than 2 times 7 minus 2, which means 8 is less than 2 times 5, or 8 is less than 10, and that is true. If I plug in 8, I get 8 is less than 8 times 7 minus 8, and I get a negative in here, so I get 8 is less than 8 times negative 1, so 8 is less than negative 8. 8 is not less than negative 8. When I plug in the negative 1, I also get a negative answer, so 8 can't be less than a negative number. And when I plug in 0, I get 8 is less than 0, and that is also not correct. Number 2, to solve this inequality, I need to add a half to both sides. But since they're fractions, I need a common denominator. So I have 2 6 plus 3 6 is 5 6. So I get Q is greater than 5 6. What does that look like here? If I look here, 5 6 is just short of 1, so I just wanted you to estimate. That should be an open circle. Sorry, this is really small. So it should look like that, okay? Just left of the 1. Number 3, your class hopes to collect 325 cans of food. There were 135 cans donated the first week, 89 more the second week. You are going to collect C cans the third week, and you want your total cans to be greater than or equal to 325. We can always use more than 325 cans. So that is 1. The only other answer I accepted is if you went ahead and simplified, and this would be 224 plus C is greater than or equal to 325. So those are one of the inequalities I wanted. And then the answer is you subtract 224 from both sides, and C is greater than or equal to 101. And it does say write it as an inequality, so make sure you do that. Okay. On this one, a few of you forgot that when you multiply both sides by a negative, you have to reverse the inequality. So x will be greater than or equal to negative 8. So remember, that's the only thing that was really kind of new and funky with inequalities, is when you multiply or divide by a negative, you reverse it. Whoops. And then you make sure and graph it the right way, unlike me. So you're exactly right. It should be greater than or equal to. And we want that right on the line there. Okay. So far, so good. Number 5. We would subtract 6 from both sides and get 4x is less than negative 12. Divide both sides by 4. So x is less than negative 3. What does that look like? Open circle at 3, shaded left. Number 6, we had to do a little distribution and simplification. So 12 plus 10w is greater than or equal to 8w plus 96. I'd subtract 8w from both sides and get 12 plus 2w is greater than or equal to 96. I'd subtract 12 from both sides and get 2w is greater than or equal to 84. Divide both sides by 2. And I get w is greater than or equal to 42. On this one I said, my bad, I should have put a blank number line, so if you just put 42, did that. On the test it'll be right. Okay? Alright, first page done. Page 2. Whenever I have the x sandwiched in the middle, it's always going to be an and. So I need to write 2 inequalities. Negative 2 is less than or equal to 2x minus 4, and 2x minus 4 is less than 8. So I'm going to, on this one, add 4 to both sides, and get 2 is less than or equal to 2x, divide both sides by 2, and I get 1 is less than or equal to x. Okay? That's half of my inequality. And then over here I add 4 to both sides, and I get 2x is less than negative 12, positive 12. 2x is less than positive 12, divide by 2, x is less than 6. So x is less than 6 and greater than or equal to 1. So what does that look like? An and. It looks like a typical and. Greater than or equal to 1, less than 6. Where are they both graphed? In between 1 and 6. Okay? You'll get a point for the inequality and a point for the graph. If you may get the inequality wrong, but you graph what's wrong correctly, then you still get the graphing points. Number 8. Add 2 to both sides. So I get 2x is greater than negative 10. Divide by 2. X is greater than negative 5. Or subtract 3 from both sides. 2x is less than 4. Divide by 2. X is less than 2. Where is x greater than negative 5? Where is x less than 2? Okay, this is where some of you are making a mistake. My answer is, where is one or the other graph? What is one or the other graph left of negative 5? Yes. Is one or the other graph at negative 5? Yes. And then, so basically, everywhere one or the other is graph. Okay? I don't want to put my open circles on this graph. If you put an open circle here, it makes it look like negative 5 is not included. But since it goes through negative 5 on this one, it is included. So you do not want to put an open circle there. You just want it to be a filled-in line, just like that. Okay? So that's the solution, all real numbers. Okay? Now, this solution is still the inequality, but the solution on the graph is all real numbers. So please make that correction. If you put the open circles on that, don't do that. Okay? All right. Let me go ahead and calibrate here, because obviously I'm off a little bit. Okay, moving on. There we go. Okay, on this one, we would add 3 to both sides and get 5x is less than negative 5. X is less than negative 1. Or subtract 3. 2x is greater than 4. X is greater than 2. Where is x less than negative 1? Where is x greater than 2? And this is going to look like our typical or going outwards. Okay? Where is one or the other graph? One or the other graph, or combine the two graphs, looks like that. Okay? All right, page 3. What is the graph of the inequality in the coordinate plane? X is greater than or equal to 4. Thank you. Okay, so on this one, we have an and, so we need to subtract 3 from both sides. So 2x minus 1 is less than or equal to negative 7. And I'm going to continue down here, whoever's popping their whatever. 2x is less than or equal to negative 6. Divide by 2, x is less than or equal to negative 3. And add 1, 8x minus 2 divided by 2 is greater than or equal to 7. Multiply both sides by 2, and I get I get 8x minus 2 is greater than or equal to 14. Add 2 to both sides. So I get 8x is greater than or equal to 16. Divide both sides by 8. X is greater than or equal to 2. Okay, thanks. I forgot to bring down the 3 on the first one. Good catch. So let's go ahead and finish the first one correctly. I make mistakes too. So it should have been 2x minus 1 over 3. So then I should have multiplied both sides by 3. And I get 2x minus 1 is less than or equal to negative 21. Add 1. 2x is less than or equal to negative 20. Divide by 2. X is less than or equal to negative 10. So let's change that. X is less than or equal to negative 10. Okay, where is x less than or equal to negative 10? Where is x greater than or equal to 2? Where are they both graphed? Nowhere. There's no solution. So you just leave it empty. Okay? You could just put a box around it to show that it's an empty number line, or just right above it write no solution. There's no solution. The inequality is this, but there is no number that's both less than or equal to negative 10 and greater than or equal to 2. Okay? Number 11. What is the graph of negative 8, 2? So this goes back to that quiz we had. Negative 8, or x remembers the comma. So x is less than, or x is greater than negative 8, less than or equal to 2. What does that look like? Greater than negative 8, less than or equal to 2, and it's in between. Because that's where they're both graphed. Okay, so you get a point for the inequality and a point for the graph. Number 12. How about this one? Well, it's an or. X is less than 8, or x is greater than 10. So where is x less than 8? Or greater than 10? Well, it's right there. Typical or. Going out like that. Okay? All right. Graphing linear inequalities. So when we're graphing linear inequalities, we first graph the line, and then we go ahead and shade correctly. So first thing I do is I know that I start at negative 5, and then I'm going to rise 3, run 1, because that's the slope. And I know that it is a dashed line because it's only less than, it's not less than or equal to. So I know that I'm going to use the dashed line. So I'll use green. Whoop. And put it where it goes. Now I need to test a point to see which way to shade. I always like to use 0, 0. If possible, is 0 less than 0 minus 5? Is 0 less than negative 5? No. So I shade to the opposite side of 0, 0. So this is what should have been shaded on your graph. Okay? So you'll get a partial credit for graphing the right line, partial credit for shading the right way. Number 14 asks you to get y alone first. Okay? So I would need to subtract 4x from both sides. So I get 6y is greater than or equal to 12 minus 4x. Divide both sides by 6 and get y is greater than or equal to 2 minus 2/3 x. Not so bad. I'm going to start at 2. I'm going to rise negative 2, run 3. Rise negative 2, run 3. That one is a solid line, so I'll go with my solid line. And does 0, 0 work? Is 0 plus 0 greater than or equal to 12? Is 0 greater than or equal to 12? No, so I'm going to shade away from 0, 0, or the other side of the line. Okay? All right, next page. X is greater than or equal to 4. What does the line x equals 4 look like? It is a vertical line at x equals 4. Where is x greater than or equal to 4? On the line or to the right of the line? Okay, y is less than negative 2. So that's going to be a dashed line, at negative 2. Where is it less? It is less below. So those ones, pretty obvious which way to shade. Okay. What do we do when it's a system of linear inequalities? Same thing, except we have to do both lines, shade both, and see where the shaded areas intersect. So the top one, y-intercept is 4. So I'm going to start at 4, and the slope is 1, so rise 1, run 1. And it is a solid line, so it's going to be solid. And then does 0, 0 work? Is 0 less than or equal to 4? The answer is yes, so I'm going to shade towards 0, 0. Okay? Then I got my second line. I need to get y alone first, so I subtract 2x from both sides. So I get y is less than or equal to negative 4 minus 2x. Y-intercept is negative 4. The slope is negative 2, 1, or positive 2, negative 1. It is solid, so I'm going to make my solid line. Okay, and then I need to decide which way I'm going to shade. Does 0, 0 work? Is 0 plus 0 less than or equal to negative 4? Is 0 less than or equal to negative 4? No, so I'm going to shade away from 0, 0. So I'll use blue and yellow make green, right? So I'm going to go this way. It's so funny. Yeah, it was. And then I see that it turns green down here because that's where they're both shaded. And you would do that by just going ahead and shading darker. Okay, so there would be, that's my solution, this region right here. All right. One more of those. We have a y-intercept of negative 1 and a slope of negative 1. And it's solid. Then we have a y-intercept of 4. 1, 2, 3, 4, a slope of 2. Or we could do negative 2, negative 1. It is also solid. Oh, well, it wouldn't shade after the fact. Okay, now let's go back and shade on the blue. Let's see if 0, 0 works. Is 0 less than or equal to 0 minus 1? No, so I need to shade away from 0, 0 on the blue. Shade away from 0, 0. How about on the red? Is 0 greater than or equal to 0 plus 4? No, so I also need to shade away from 0, 0. So not this way, but this way. And again, the green region then is the solution. If I extend this line here, go ahead and extend that. And go ahead and make sure that I'm accurate here. Okay, good enough? All right, a couple more of those. These are a couple of interesting instances that I thought would be fun to have on there. So fun. So here we're going to start at 4. I can't go 5 and 1, but I can go negative 5, negative 1, negative 5, negative 1. This is going to be a dashed line. So I'll just go with that one right there. Okay. Does 0, 0 work? Is 0, let's go blue here, is 0 greater than 0 plus 4? No, so I'm going to shade away from 0, 0. Okay? Now this is really interesting. Someone said, Mr. Hildahl, these are parallel. What do I do? Well, let's just do it. Let's do what we were trained to do. Graph the slope and the y-intercept. 1, 2. Okay, graph the line. And then does 0, 0 work? Is 0 less than -3? No. So I need to shade away from the... Okay, so really, what is the solution?
No solution.
No solution. Good. But we show that as no solution as there's no intersecting of shaded areas. Okay? So that one actually is no solution. Now on this one, if you get y alone, by subtracting 2x, you have 4y is greater than or equal to 12 minus 2x. Divide by 4, and you get y is greater than or equal to 3 minus 1/2 x. And then you go, wait a minute, what's what that one is, right? Okay, so, well, let's graph it. 3, -1, 2, -1, 2. It is solid. And then we go, okay, well, where do I shade? Does 0, 0 work? Is 0 greater than or equal to 3 minus 0? No. So I need to shade above. And then I go, well, what do I do for the other one? Well, it's exactly the same. So there's all the solutions are, so then I go ahead and shade the other one, and then I realize that this is all everything above is the solution. Tons of solutions. Well, it would be infinite, but this is the graph should just look like that. Everything's shaded the same direction.
Technically, it would be half of infinity, but really you can't really define that.
Right.
Even half of infinity is
Infinite. Okay. This one here, if we start at 4, so I'm going to let's use some common sense with multiple choice. Eliminate the -4s. Now you've got it down to 2, right? Okay. Is the slope -3 on both? Well, obviously it is. So we're done with the line. Now we just have to figure out which one does the point work. We want 0, 0 to work, right? Because that's the way it's shaded. So for which one does 0, 0 work? 0 is greater than or equal to 4. Is that true? No. B. Okay. Same dealio here. You can eliminate the +4s because the y-intercept is -4. The slope, so I just have to check the point. 0, 0 needs to work. Is 0 less than or equal to -4? No. Those ones aren't too bad. This one I did make you come up with the equations all by yourself, just because I thought that was important. So, what about the first equation? I'll call this one my first one. It doesn't matter. It doesn't matter, yeah. So what's the y-intercept of this one? 2. What's the slope? Well, I'm rising 2, running 2, so the slope is 1.
Isn't that -2?
Yeah. My bad. -2. Okay. A slope of 1. And I want 0, 0 to not work. So I think it's going to be greater than or equal to. Is 0 greater than or equal to -2? Yes. I don't want that to happen, right? I don't want 0 to work. So I need to change that to less than or equal to. Okay? Now my red line. It has a y-intercept of -6. It has a slope of rise 1, 2, 3, run -1. Is that what it is? And my grid doesn't show it very well. Hopefully yours does better in your paper. So it's -3. Um, and then y, and we want 0, 0 to not work for this one as well. Okay? So if I think it's, I'll just say it's greater than or equal to. Is 0 greater than or equal to -6? Yes. So I chose wrong. So I'm going to make it y is less than or equal to. Okay? So that's what you should have gotten on that one. This one, I made it, I tried to make it nice and simple for you. So it shouldn't be too hard to graph if you did it right. What is my equation? So it does say to write and graph a linear inequality. So what is my linear inequality? It is $7 for each album download plus $8 for each movie download, and I need to spend less than or equal to $56. What would be the easiest way to graph that? X and Y intercepts, right? Okay, my x-intercept when y is 0 would be 8. My y-intercept, I'm thinking of Parker because he made this one harder. My y-intercept, I make x equals 0 and I get 7. The reason that makes it so easy is I know what values are going to be on my x and y axis, so I can just go 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. I do want you to label your graphs. This is albums. This is movies. I'd call it downloading or downloads. Okay. And then we go, okay, what is my x-intercept? 8. That means I could have 8 albums, no movies. 7 is my y-intercept. That's 7 movies, no albums. It would be a line segment because I can't go into negatives. And then could I spend less than $56? Sure, that would be the best. So my solution is everything in here. I could do 2 and 2. That's less than or equal to 56. I could do any combination of ordered pairs in that shaded region.
Or they could steal some.
Yeah, but we don't do that. They could.
Parker does. Parker does.
Okay, this takes you back to the system of equations from last unit. I thought that would be a good bonus. Not terribly difficult if you remember what you did. So if x equals the number of veggie wraps and y equals the number of chicken wraps, then I just go $1 for every chicken wrap plus $1.80, or I mean $1 for every veggie wrap plus $1.80 for every chicken wrap is $98.80. That's how much I spent on my veggie and chicken wraps, or were spent on them that day. How many veggie and chicken wraps all together? 70. So if you solve that system of equations, I would have just multiplied the bottom one by -1.
Yeah.
Then I could eliminate x, and I just get 1.8 minus 1y is 0.80y equals 28.80. Divide both sides by 80 cents, and I get 28.80 divided by 0.8, 36. What is 36? Chicken wraps. If there's 36 chicken wraps, how many veggie wraps are there? 34. What are we asked? 34 veggie wraps. Okay. So there you have it. Let me remind you that in Google Classroom, I have placed, in Google Classroom, I have placed, oops, I was in Google Classroom. Here's your class. Google Classroom, I have put some Khan Academy videos, some Jeopardy practice that we're going to do now, and a extra credit quiz it is. It did?
You have to, if you click here, you have to log in.
Right, so if you go here, and then you log into Quiz and use that code.
It said that code wasn't valid.
It did? Okay. Well then, let me, I'll try it again. I'll load it here in a second, okay? I don't know. I have to go back and look at it.
We could do quizzes right now.
Thanks. Quizzes